Good afternoon, everybody. Hope all is well. Today I'm going to be talking about directional drilling, specifically how turns are made. My name is Brandon Munoz, so let's get started. Here's a cartoon illustration showing what directional drilling looks like. In the top right corner, you will see a city located over an oil deposit, also known as a pay zone. Since companies can't set up a rig right next to a city, they will set up far away but gradually drill an angle to get to that pay zone. Another great aspect of this picture is that it shows multiple holes stemming from one hole. Companies will save money by tapping more pay zones and only drilling one hole. They will also reduce their environmental impact. This is a really exaggerated illustration, but I thought it served a great purpose. So now let's get into how holes are made. It all starts with the bottom hole assembly. There are many components to the assembly, but I'm only going to mention a few. The first one being the GPS. For obvious reasons, the GPS is crucial to the operation because it lets the operator know how deep they are, how much further they need to go, when they need to make an adjustment. Next, we have the rotary steerable systems. The operator has direct control and can maneuver the drill bit manually. He's able to deviate in a few different directions with minor degree adjustments. Next, we have a stabilizer. Stabilizer is located on the drill pipe and keeps the drill from deviating away from the path. Finally, we have the measurement while driving tool. The MWD is a crucial sensor of the operation because it provides feedback to the operator, letting them know how fast they're drilling and what kind of vibrations they're experiencing. These aspects are crucial because they can determine the drilling method used as well as the change in the bottom hole assembly. Here's an illustration of what the bottom hole assembly looks like. Notice you have a stabilizer located on the drill pipe. This is to keep the drill bit from deviating in any other direction other than the direction noted by the operator. Next, we have the MWD. Notice how the MWD is located on the bend sub. This is because it needs to maintain contact with the surface in order to provide feedback to the operator. The feedback provided will let the operator know if any changes need to be made in the drilling assembly. Also notice that there is a bend sub. This bend sub is there in order to create turns and to create trajectories for the operator. I will mention a few methods on how this is used in the next slide. So now that we have an idea of the drilling equipment used, let me talk about some of the methods used to create these turns. Push the bit. This uses the bend sub mentioned previously to push off the sides of the hole of the wall to direct the drill bit in the desired direction by an operator. Once the operator creates this turn, the turn is now referred to as the drill kickoff. Point the bit method. This uses a rotary steerable system that is manually controlled by an operator to turn the bit in a direction. The operator will maneuver the bit until the drill kickoff is created. Next, we have whipstock. This method is when you drill a hole and you take your drill out and you insert this whipstock and you reinsert your drill. Now this whipstock is special because it contains a curve. Now the drill will follow this curve and create that drill kickoff. Lastly, we have jetting. Jetting is when the drill bit nozzle releases high pressure fluid that clears the path for the drill bit. Jetting is also combined with push the bit method. Here's the angle that I was talking about for the whipstock. You can see the drill head just follows that path and gradually creates that curve. Here's an illustration of what jetting looks like. I will show you a better video later on. As you can see that the drill bit releases a high pressure fluid and the drill head just follows. It's also important to know that the drill head is not spinning at this time. The only action happening is the jetting fluid. Here we have push the bit. You can see that the bent sub is directly pushed up against the wall, creating an angle which the drill bit can approach. Here we have point the bit. The point the bit contains a shaft that the operator has direct control over. Now the operator can't turn 90 degrees, but he can turn 5 degrees and gradually make a curve. Now I could talk about the drilling assembly and how the turns are made all day long, but I wanted to show you this video because it provides a visual representation of what I've been talking about. I hope you now have a better idea of what I've been talking about. So in summary, horizontal drilling can't be covered in 7 minutes, but I just wanted to cover the main components as well as the main methods used in creating turns. This process begins with the components of the bottom hole assembly. Once the drill is in the ground, the feedback from the assembly will let the operator know if any additional adjustments need to be made. Once additional adjustments are made, the drill bit will be on path to create a drill kickoff. Appreciate you guys watching. I hope you learned something, and thanks again.